Hello, geometry students. How's everyone doing? Okay, so what do I got here? Uh, this is a thing called Toblerone. Okay, it's a chocolate. I think most of us have probably seen it at one time or another in any place that sells candy bars. For some reason, it's a popular candy bar. I don't know if I ever have eaten, but I've always been fascinated by the shape of its box. Okay, it comes in a box. First of all, it's not comes in a wrapper. While most candy bars usually come in a wrapper, this one it's Swiss. It's made in I guess it's Swiss. I don't know if it's actually made in Switzerland, but it's a Swiss company or the maker is from Switzerland. It says here. I don't know if you can read that. It's a German name, Toblerone. I don't know what that means in German. I'd have to ask my father. But the idea is that I see these all the time. I remember my dad pointing out this chocolate. Oh, this is very good chocolate. I wasn't a big chocolate fan, so I didn't really care. But I always thought it was cool how it came in these boxes. And what happened was I found out this was what they call a triangular prism. It's a three-dimensional shape. You got a triangle here, you got a triangle here, enough to fit this. And you have 1, 2, 3 rectangles. So that's where I think of this from. So if you have been and you've seen this before, I want you to have that vision of what this thing looks like in your head because we're about to mentally tear it apart because I can't physically tear it. Okay, I don't have a Toblerone on me. So it says, what is the surface area of the triangular prism? Now, we've been talking about areas. Now, when I think of surface area, what I usually think of is wrapping paper. Like, how much wrapping paper would you need to cover this thing? Now, if I'm thinking of this was a present, I was going to give you a present of Toblerone for Christmas. I don't know, I could give chocolate at Christmas, right? I would have to wrap it up, and I'd have to make sure I have enough wrapping paper to cover all the sides and all the ends and everything, and you'd be surprised when you open it up. So I need some wrapping paper. Surface area is like the wrapping paper, so it's got to cover every piece. They say use a net. This is not a fishing net or a basketball net. This means this. If I take this shape, my triangular prism, and I were to take it apart, it would look something like this. You think about opening that Toblerone box. Maybe one of you has the opportunity to go to, 7-Eleven. You buy that and you rip it open like this. So that's how you take the box apart. And I realized something about this box. Well, the box has 2 triangles, 1, 2, 3 rectangles. Okay, so I'm going to do this the long, hard way. There's no real formula for the surface area of a triangular prism. What there is, though, is I can use different pieces of this. Okay, so what am I going to do? So first thing I look at is I say, well, I got these triangles here, and if I imagine this and I use the information given to me, I'm going to use some black numbers here. These 2 sides of the triangle are 5 centimeters and 5 centimeters. This one on the bottom is 6. So from here to here is 6. And since these 2 triangles at both ends have to be the same, they look like this. Now the problem is I look at this rectangle over here. There's another rectangle right here. Its one side is 5. And its long side here is 12. So as I label this whole thing up, I tore it apart. Now I have some issues. I always have issues. Okay, so my issue here is the triangles. Well, I know the area of a triangle. Area equals 1/2 base times height. My triangle looks like this. I got 5 centimeters here, I got 5 centimeters here, I got 6 centimeters here. Now, I have a base. Okay, 6 is my base. But the problem is I don't have a height. I have these sides, but I don't have a height. I need this to know what this is. That's my height. Well, number one, this is an isosceles triangle. Saves me a lot of trouble. Okay? That means that this cuts this shape perfectly in half. So this is 6, but this little one here is 3. From here to here, let me highlight that with a different color. Orange. That's 3. This is 5. So what is the height? Look at a right triangle. I'm good with right triangles at this point. I could do two things. I could know this is a special triangle. This is what we call a 3, 4, 5 triangle. I have a 3, and 5 is the hypotenuse, so the height must be 4. But if I don't remember that, I can still remember this. A squared plus b squared is equal to c squared. So since this is the hypotenuse, that has to go there at the end, right? C is always the hypotenuse. B squared could be, I guess we could put A here, 3 squared plus b squared. So we're solving for b. 3 squared is 9, plus b squared equals 5 times 5 is 25. I have to subtract 9 from both sides. Not there, there. And I get that's 0. B squared equals 16. I square root both sides, and I find that b equals 4, which is I told you earlier, but if you remember it's a special triangle, you're lucky. You save a lot of time. Now, let's do this. Now I can do this. I have the height. A equals 1/2 base times height. 1/2. My base is 6, right? And the height is 4. 1/2, 6 times 4. So 1/2, 6 times 4. Well, 1/2 of 6 is 3. I would put this in the calculator, but I'm trying to save time for you. But you can put it in the calculator. 6 times 4 is 24. Half of 24 is 12. So the area of my triangles is 12. 12 centimeters squared. So that's how much wrapping paper I need for the triangles. Now, the next thing is important to remember that these are the same triangles, right? Same numbers, 5, 5, and 6, 5, 5, and 6. So I calculate one, I have to know the other. That's good. Now over here, I'm going to look at this triangle. Let's say I'm going to make these outside triangles in blue. Highlight them in blue. And what's the area of this one? And this one happens to be the exact same one, a 12 by 5 rectangle. Well, if area for a rectangle equals base times height, 5 times 12, I put that in my calculator. That's supposed to be an H, by the way. Base times height. Put that in the calculator, and the area equals 60. Okay. So I come over here. I know the area here is 60 centimeters squared. Here it's 60 centimeters squared. I'm almost done. There's another rectangle in the middle. This one is different because from here to here, we already know is 12, and from here to here is 6. So instead of area equals base times height being 5 times 12, now I'm doing area equals base times height 6 times 12, which is 72. Did that one in my head. So this middle guy here is 72. So now what's the surface area? Well, this is what we can do. I can take all this information and just add it up. I'm adding up the area of all the individual pieces. This is a shape, a triangular prism that's made of 2 triangles and 3 rectangles. So I just add them up. 12 plus 12 plus 60 plus 60 plus 72. This one, I'm going to use the calculator for. Maybe. Yeah, I will. Being lazy. Could do this in my head, but I decided not to. So I go 12. Sorry, 1 second. Almost done. 12 plus 12 plus 60 plus 60 plus 72. The surface area of this pyramid, it would take me 216 square centimeters to wrap this candy bar up for you and give it to you for Christmas. Merry Christmas. Even though it's almost June. All right. I'll talk to you guys later.